Hey guys, so we're in lesson 8.7 on solving one-step inequalities. So this is just like solving equations, except for this has an inequality sign, which means we have an infinite number of answers, which means we're going to need to graph the answer eventually. Now this is going to be a word for screen. I'm just going to write a little bit, then I'm going to go to a new screen because I want a whole screen to write the rest of the stuff for the notes parts. So, first things first, to solve inequalities. Oh, can you hear the sirens in the background? Somebody's in trouble. To solve inequalities, follow the rules. The rules for solving equations. Now, I gotta say, some of you did a great job on showing me how to solve equations properly, and some of you did not. There is no option as to how you show your work. There is one way, and we're going to learn how to do it correctly, because next year they're going to build on it. So, I'm going to yell at you for a little bit. What's the process? We're going to do inverse operations to both sides of the inequality with the number that is on the same side, almost there, as the variable. Try that again. There we go. Okay. This is something very important. Now, this is the thing that I saw that does not work for me, and it is not learning how to solve appropriately. Do not guess. And that's what I kept seeing people doing. They would guess the number that would replace the variable, but that's not what we want to do. Okay, so do not guess. Now, this is not Miss Rosner being rude and has to do it her way. No, this is how we start the problem-solving process of solving an equation appropriately. Okay? Super, super, super important. Okay? All right, so just as a quick reminder, if my problem has addition, I'm going to use subtraction on both sides to clear out the number so that the variable is all by itself. Okay, whatever I do to the left side of the equation, I do to the right side. If I start with subtraction, then I'm going to use addition. If I start with multiplication, I'm going to use division. Now, division, when I'm dividing, that's the only time that you're going to see me use a line for division. I saw some people who every time they did anything, they drew lines underneath the numbers and then did the math, even though they use like a subtraction sign. So that actually means you're dividing by a negative number, right? So you got to know what you're saying. And I'll take what you tell me literally. And if it's not the right math, then I'm going to let you know that. And again, if you have division, the way to undo that is to use multiplication. So you guys are going to keep writing on your first page, but I'm going to go ahead and move to the next screen so that I have full screen to write everything I want to write. Okay. All right, so we're going to do 4 different equations. We're going to do an adding equation. X plus 2 is greater than 5. We're going to do a subtracting equation. X minus 3 is less than or equal to 7, and you know me, I can't help myself with the x's. Then we're going to do, and then we have 2 times x is greater than or equal to 10. And then last but not least, we have x divided by 7 is less than 12. Okay, so just as a reminder, put it over here, our goal, get variable alone on left. Okay, now this is super duper important when we do inequalities, is because if the variable comes first, then the inequality will be pointing the direction to draw the graph. All right, so we're going to go step by step how to do this. It's going to sound very much like what we did before. Number 1, locate the variable. That side with the variable is going to tell us all the action we need to do and what we're going to do it with. 2, we're going to identify the operation, and operation means adding, subtracting, multiplying, or dividing. Yeah, there's 3 questions on the quiz that a lot of people miss, and it was always based on vocab. You gotta know the words. So identify the operation, adding, subtracting, multiplying, and dividing, happening to that variable and the number the operation is working with. So one side, is going to have 2 players, a number and a variable with an operation happening between them, and the other side is going to have a multiplication, or is going to have a number by itself, okay? So that's our second thing. So let's go back to our problems. So I'm going to write out x plus 5 is, x plus 2 is greater than 5. X minus 3 is less than or equal to 7. 2x is greater than or equal to 10, so that's 2 times x, and last but not least, x divided by 7 is less than 12. So what we're going to do is we're going to identify the operation and the number. So I'm going to go ahead and use that color highlighter. So right there, you can see that we are adding 2 to the x. And then here, we are going to be subtracting 3 from the x. And then here, this one's kind of a hard one to see, but if we've got a number butted up to a variable, that means we've got some multiplication going on. So that's going to be multiplying by 2. And then the last one over here, we're going to be, kind of caught the x in that one. Let's see if I can do that a little bit better. Maybe focus it. Yeah, a little bit down there. That looks better. And then that's going to be dividing by 7. Okay? Once we've identified it, now we're going to act. And we're going to use inverse operations. Remember, that was on our other slide. So it's the operation that is the inverse of the one that's there. You use inverse operations with that number. So the one we've highlighted and wrote underneath. On both sides of the inequality. In order to get the variable alone on the left and solve the problem. Okay, so here we go. I'm going to write down my equations again. Oops, wrong color, sorry. Let's get back to purple. Purple, come back, purple. X plus 2 greater than 5. X minus 3 less than or equal to 7. 2 times x is greater than or equal to 10. And x divided by 7 is less than 12. Okay, so now here's how we show. Now where I'm placing the numbers is where you need to place the numbers. So I'm going to do them all in the same color. So the inverse of adding 2 to x would be subtracting 2. We're going to do that on both sides. The inverse of subtracting 3 from x is going to be adding 3, but to both sides. So when I'm talking both sides, on either side of the inequality symbol. The inverse of multiplying by 2 is dividing by 2, and I use the fraction bar to show division. Now the last one is the tricky one. Placement is tricky on this one. The inverse of dividing by 7 is multiplying by 7. I need to put it up in the top, so I have 7 over 7. And I put the 7 on the right side anywhere I want. Okay. So then the next step is we're going to write the answer. Now, when it was an equation, we had variable equals answer. On this one, we're going to have variable, and then inequality symbol, and when I say variable, I mean like choose a letter, and then number. That's how the answer will look. Okay, so first problem. Let's see, if I subtract 2 from both sides, that leaves me just with x is greater than 5 take away 2 is 3. On the second one, if I add 3 to both sides, that just gives me x. When I add opposites, I get 0. And then 7 plus 3 is 10. 7. Yeah, sorry, I lost where I was. There we go. Okay, 2x divided by 2. 2 divided by 2 is 1. 1 times x is greater than or equal to 10 divided by 2 is 5. And then last but not least, x divided by 7 times 7, so 7 divided by 7 is 1, 1 times x is less than, and 12 times 7 is 84. Now, we're not done because these are inequalities. So the last step, now, in order somebody can see what my answers are, we're going to graph the solution. On the number line. Okay, so let's graph the first one. Now I only need 3 numbers. The number that's part of the answer goes in the middle, then whatever is smaller first in front of it, and then the bigger number, then it goes right after it. Now, I have to look at the inequality, okay? And it's going to tell me what to do. So when I look at greater than, that means 3 is not an answer. So I'm going to put an open circle. Now, the inequality is greater than, which means I'm going to color to the right. So we're going to put an open circle on the 3, and then we're going to really exaggerate the inequality coloring in it. Should be no doubt in my mind what you're trying to tell me the answer is. Okay, let's look at the next guy. Let's see. We've got less than or equal to, so that means 10 can be a solution. And if you notice, it is going towards the left. You know what? I don't like that. I'm going to put it over here. It's pointing to the left. Okay? So let's put our number line up. 3 numbers. Only time I would put 4 is if I have a mixed number and I need where in the middle would be the two whole numbers that the number falls between. 10's going to go in the middle, 9 in front, 11 in the back. So we're going to go to where 10 is. We're going to color in that circle, and we're going to color to the left for less than. Really exaggerate it. Okay, next problem. Let's see. We've got greater than or equal to, so that's going to be a closed circle because that means 5 is a solution. And then we're going to color to the right for greater than. So let's see, we're going to get our little number line. 1, 2, 3 numbers, 5's in front, or in the middle, 4 in front of it, 6 after it. Then we're going to go to 5. We're going to put a closed circle, and we're going to color to the right for greater than. You know what I really like about this stuff is the fact that I get to color. I like the color, in case you haven't noticed that. Okay, I've got a less than symbol, so I'm going to have an open circle because it says 84 is not a solution, and then I'm going to color to the left for less than. So you always are analyzing what you got. All right, last number line. 1, 2, 3. 84 goes in the middle, 83 in front, 85 in the back. So we're going to have an open circle at 84, and then we're going to color to the left for less than. So we got to know what kind of circle we're doing, and we got to know what direction we're drawing. So let's go ahead. We're going to go to the next screen, and we're going to solve probably 4 problems. And we're going to show them with the work all next to it so you can see what it really looks like. So it just says solve, then graph the solution. So this is the only part that we didn't see when we were doing equations. We didn't graph it because it was just an answer, right? All right, so first problem. X minus 1/2. See, you thought, she's only giving us whole numbers. Yeah! No. So I'm going to demonstrate all of these with some fractions. We have x minus 1/2 is less than 2/5. Okay. So remember what we're doing. Let's deal with inverses. So the inverse of subtracting 1/2 is adding 1/2. And we're going to show it on both sides of the inequality. When I add opposites, they zero out. Now, a lot of you in your last videos, what you were doing is you were just showing a line and a 0. You didn't put the 1/2 and 1/2. That was kind of strange. Now, here's the deal when it comes to fractions. You can't add or subtract them unless they have a common denominator. So I'm going to create 2 new fractions that have the same denominator. So let's see. 2 doesn't go into 5, so the easiest is just to multiply 2 times 5 is 10. So I'm going to multiply 5 by 2 to get to 10. So I multiply the numerator by 2, and I get 4/10 for 2/5. On the denominator, I multiply 2 times 5 to become 10. So I multiply the numerator by 5, and I get 5/10. Now I'm adding these, and 4/10 plus 5/10 is going to give me 9/10. Okay, so now I'm going to show you how to graph this. Because this is a fraction, I'm going to not have 3 tick marks, but I'm going to have 4. Then I think about what 2 whole numbers does 9/10 fall between? Well, 0 and 1. So in front of 0 is a -1, after 1 is a 2. Remember, we've got that number line in class. And you can just kind of look that over. So now I'm going to estimate where I think 9/10 is, but I'm going to tell the person who's reading my graph that's 9/10. I'm going to analyze my inequality. It says less than or equal to, so that means it's a closed circle since 9/10 is one of the answers, and then I'm going to color to the left for less than. So at 9/10, there's my closed circle. I'm going to kind of make a fat graph and definitely a fat arrow cap. Okay? Awesome. Let's try the next one. Is she going to do more fractions? Well, let's see. Nope. Going to do decimals this time. Y plus 2/3 is greater than 2 and 3/10. is greater than 8 2/10. So we identify what's happening to the variable. I'm adding 2/3. So the inverse would be subtracting. There, I said 2/3 again. 2 3/10. And I'm going to do that on both sides of the inequality. Okay. When I add opposites, I get a 0. And that gives me y is greater than. And then I'm going to do my math over here. So I have to rename. 12 take away 3 is 9. Then we have the decimal point. And 7 take away 2 is 5. Okay, so I get my answer is y is greater than 5 9/10. All right, so I'm going to go ahead and graph that. So again, I'm going to have 4 tick marks on here. And the two whole numbers that 5.9 falls between, it's between 5 and 6. In front of 5 is 4, after 6 is 7. So I'm going to make a mark where I think 5.9 would be. I label it so my audience knows. Now I'm going to analyze my inequality. So greater than means it's an open circle because 5.9 is not a solution. And then it's pointing to the right. I want only the numbers that are greater than that. So open at 5.9 and color to the right for greater than. Okay, let's try another one. Okay, number 3. Let's see, we have 2m is greater than or equal to 1.5. So a whole number and a decimal. Okay, so first thing we do is identify what math is going on. I'm multiplying 2 and m, so the inverse of multiplying by 2 is dividing by 2, and this is how we show it. I saw some people were doing the fraction part and the division symbol. That's like saying divide, divide. You only get 1. So here's where it gets a little different. 2 divided by 2 is 1, not 0. Okay. All right, so then that leaves me with m is greater than or equal to, and let's see. I'm going to do the math off to the side. So down and out, and the 1.5, the numerator, is the dividend. So bring the decimal point up. 2 can't go into 1. Let's see, but 2 can go into 15 7 times, which is 14. Subtract, I have a difference of 1. That's where I annex a 0 and continue dividing. 2 goes into 10 5 times evenly. So I get m is greater than 75 hundredths. So I'm going to do my graph. And again, because I have a decimal number, 4 numbers here, I get that falls between 0 and 1. So negative 1 is in front of 0, 2 is after 1. So I'm going to make a point where I think 0.75 is, say that's about there. Let's analyze the inequality. Greater than or equal to, so it's going to be closed because 75 hundredths is a solution, and then I'm going to color to the right for greater than. So closed circle. Come on, there you go. At 0.75, and I color to the right for greater than. All right, one more. 4. We got, oh yeah, the doozy, right? We have 3/5 x is less than 12. Now, when we talked about this with equations, what I talked to you about is to multiply by the reciprocal, and so I'm going to give you a second way of doing this. So first things first, I have to get rid of the denominator. To do that, I'm going to multiply both sides by 5. Why multiplying? Because I'm dividing by 5. Okay, so that's going to be 1, and then I get 3 times x times 1 is 3x, is less than, and 12 times 5 is 60. Then I can divide both sides by 3. So instead of doing it in one step, I can do it in 2 separate steps. But always start with getting rid of the denominator first by multiplying both sides. So again, we get a 1, and we get x is less than 20. Oh, look at that, finally. 3 tick marks only. 20 in the middle, 19 in front, 21 in the back. Let's analyze that inequality. It's less than, so it's open circle, meaning 20 is not a solution, and we color left for less than. Open at 20, and color to the left for less than. So hopefully this kind of made a little bit more of a, oh yeah, now I get it, for those of you that are struggling with it, and for those of you who weren't struggling with it, now you're going, okay, yeah, the good reminder. All right, have a good one, guys. We'll talk to you soon. Bye now.